boys and girls. I trust that your lesson in computers was well. Good. As I said before, we're going to be doing a special science lesson today. We have looked at the entire chapter overview, as we should at the beginning, but before we do that, we're going to look specifically at the components or the elements that are involved in what we want to talk about. Okay? We know that we're going to be talking about force, and I chose an appropriate image. Those of you who are Star Wars fans will know who that is. Alright, and we want to explore and examine really carefully from a scientific as well as educational point of view what force is all about and how we can apply forces for our own benefit in everyday life. So, the question today we want to ask ourselves is, what is force? And so we're going to examine what force is. There are specific learning outcomes which I have already prepared ahead of time for you, and they are on worksheet 1. So if you check out worksheet 1, okay, we are just going to look at our 3 learning outcomes. I'm just going to go through them briefly because that is how we want to look at this and make sure that each of you is clear on what the 3 learning outcomes are. Remember, what is a learning outcome? Who wants to tell us? What is a learning outcome? Yes, sir.
A learning outcome is what we need to know.
Okay, learning outcome is what we need to know. Okay? And we also have what is known as success criteria, which is how we know that we know
what we need to know.
Excellent. Okay, success criteria is very important because it allows us to know that we know what we need to know. Okay, so first of all, learners yourselves will be able to explain what a force is and how it is measured. Okay, that is the first learning outcome that's on your worksheet. Secondly, learners will be able to identify the common effects that forces have on stationary and moving objects. Okay, remember there's stationary, which is your pens, pencils, rulers, and then there's stationary, which means not moving. Okay, stationary with an A means not moving. And the third learning outcome that we want to achieve during this lesson is that learners will be able to recognize what friction is, okay, and how it affects motion. So we'll guide you through the experiments and the activities that we're going to do together. It's going to be fun, it's going to be enjoyable, and you're all going to be involved in learning and understanding what you need to know. Okay, so first of all, we're looking at this very interesting diagram. Now there's a question there. Theodore, would you like to read your question that's on the board?
What kind of force do you see in the diagram?
Okay, what kind of force do you see in this picture? Okay, now you've got some cards in front of you, and on your cards there is a green card and there's a red card. On your green card, there is the word, read it for me.
Push.
Say it again.
Push.
Yeah, so we want to try and look at the different types of forces that we encounter in everyday life. So there could be a push force, or there could be a pull force. Okay? Now, based on what we've learned with forces, I know that lower down you have learned about forces, and you probably have already heard the definition that a force could be a push or a pull. Okay, but we want to examine this more carefully today and try and figure out, do they understand how forces work and the effects that they have on moving or stationary objects. So what I want you to do is in each of the questions that we're going to be looking at now, I want you to identify whether you think it's a push or a pull. Okay, so the first diagram is there, we can all see it. So you can hold up your card, don't worry about that, it's because the aircon is just not one of those things. It's okay, it's so hot today, but we're not going to worry about it. Okay? So what I want you to do is identify whether it's a push or a pull. So hold up the card that you believe illustrates the type of force that's there. Let me see the card. I want to see what you're holding. Fantastic. Well done. Well done. Okay? So you all think that that's a push. Okay? Well done. What about this one? What kind of force do you see in this picture? Is it a push or a pull? Okay, you will identify that as a pull. Well done. Okay, next diagram is what kind of force do you see in this picture? Alright? Wow, excellent. Remember to hold up your words very clearly because I don't know what love is. Pull. Okay, that's good. Well done. Excellent. Let's look at the next one. Okay, what about this one? Think carefully before you answer. Okay, what kind of force do you see in this picture? Is it a push or a pull? Okay, you all think it's a push. Now let's talk about this a little bit. Why do you say it's a push? Put up your hand. It's called a push-up, but why is it called a push-up? Yes. Okay, because obviously a pull of gravity in your body, but you're pushing against it with your shoulders and your arm muscles. Okay? So that is why you correctly said earlier on, thank you very much for that definition, is it's a push up. Okay, so that's the kind of force that's working. So well done for recognizing that in the team that you're responsible for. Excellent. Well done for that. Okay, let's look at the next diagram. Okay, what kind of force do you see in this picture? Is it a push or a pull? Now, okay, somebody said push. But let's discuss. Is the dog pushing or pulling? What is the dog doing in that diagram? Pushing. The dog, is it pushing or pulling? Pushing. In terms of color, what is it doing? It is? Is it pushing or is it pulling? It's trying to pull away from the owner. Yes? And Rahim, what is the owner trying to do?
He's trying to pull the dog.
So the owner is pulling the dog, and the dog is trying to pull away from the owner. So they're both pulling. Okay? You can think of other examples of that sort of thing can happen. Where there's two pulling forces working together. Yes?
When you're playing tug of war.
We can play tug of war. Interesting. Well done, Rahim. Tana?
When you're stretching an elastic band.
When you're stretching an elastic band, and there's a pulling force that's pulling in two directions. One arm is pulling there, the other arm is pulling the other way. So well done for that. Excellent, excellent responses. Okay, let's look at this. What kind of force do you see in this picture? Is it a push or a pull? Alright, you're all correct, well done. Okay, it's a pushing force. Okay, so the old man there is pushing his trolley and doing some. Look at that, look at that, look at that. Remember Rahim's example earlier. Okay, what kind of force do you see in this picture? It's a push or a pull? Pull. Pull force. Okay, and all your cards are saying the correct thing, so well done for that. Okay, and then the last of the diagrams, what kind of force do you see working in this picture? Okay, looking at your cards, examining your answers. Alright, I think you're all independently answering and expressing your thoughts and ideas. Well done, brilliant. Okay, I think everybody has a good idea of what a push and a pull is. But we want to then define from a scientific point of view what is a force. Does anyone want to try and define what they think a force is?
A force is a push or a pull.
Okay, a force is a push or a pull. Very correct. But a push or a pull that does what exactly? A force is a push or a pull that does what exactly? Yes.
That's either stops or moves.
Either stops or moves an object. Okay, I like that. I like that. Okay, so can we basically say that a force is a push or a pull that either causes movement or stops movement? Are we in agreement there?
Yes, sir.
If I play a game of rugby and a player wants to break free from a tackle that is running in my direction, I can literally use a pushing force to stop them from advancing where they're going. How many of you ever watched American League football? You've ever seen the way those guys tackle each other? They use a lot of force. Sometimes they push the player out of play. Okay, you ever seen that?
Yes.
Yes? So those are examples of uses of forces in everyday life. Okay? So we want to be able to scientifically define a force as a, together, a push or a pull. That does what?
That causes or opposes motion.
Very good. What is motion? What is another word for motion? Movement. Okay. So a force can push or is a push or a pull that causes or opposes motion. Okay. Very, very good. Now if you look at worksheet 1, alright. You've done this exercise together. Now I want you for the next 2 to 3 minutes, you're going to get into your think, pair, share groups, and you're just going to recap what we've just looked at. So very, very briefly, I want you to fill in worksheet 1 together with your think, pair, share groups. We've already told you you're going to be pairing and sharing for today. So I want you to fill in that worksheet, including the definition for force. Yeah, I'm giving you 3 minutes to do. Listen. Big patient. Remember to keep social distancing. You want soft and let's shake, think, play, and shake so we can fill in worksheet one, working together on this exercise. There. Right? Well, that's walking around and checking to see what everybody's doing. Go to your groups if you forgot it. All the information is stored on our blackboard here, and we're just sharing. Okay. So fill in worksheet one. Okay. Underneath each of those diagrams, you write a pull or a push after you've written down the definition of a force. Okay. Definition of a force first, and then you identify. Who's working with Nikita? Thank you for sharing. That's fine. Okay. Excellent. I want to see collaboration. I want to see thinking, hearing, and sharing. Okay, share your answers together. If anyone in your group gets it wrong, you all lose a mark. Okay, so work together. Okay, empower each other and share your learning ideas. Okay, think, pair, share. I've got a list of who's in which group, so make sure you work together to get these right. Done. That's good. Got 2 minutes. Very good. Excellent. You tell us if you've been in this group, are you enjoying this? That's good. That's good. Well done, Falalelo and Funda. Looking good. Looking excellent. Okay. Done. Well done. Brilliant. Push, pull, push, pull. Okay guys, thank you very much for the 5K share activities. Let's go quietly back to our desks, okay? And we've all filled in our answers. Thank you for sharing your expertise with each other in scientific knowledge. Education is about caring, sharing, caring. All that amazing. Now, pay very, very careful attention to you as we go to the next part of the lesson. Okay, we've defined what we know from a scientific point of view that force is. Okay, we have 3 learning outcomes. First learning outcome we wanted is to be able to understand, define and explain what a force is and how it is measured. Now, from your experience and from your knowledge and even from the exams that we've done leading up to this point in time, we said that force is measured in what? What did we say? Force is measured in what? In newtons. Okay, named after which person? Newton's named after? Sir Isaac Newton. Okay, if you remember at some stage we were talking about force, weight, and gravity. I think it was another topic that we did, which is a topic that we do before we do this topic, which is just forces of motion on its own. Okay, we've identified who Sir Isaac Newton was and how he came up with these amazing concepts that help us to understand the world of science today. Now, I want to ask you a question. Okay? And as we get ready, I want you to ask a question. I'm going to ask a couple of volunteers to come. Okay? Somebody to come to the front of the class, because we're going to ask what effect does squeezing the tennis ball have, but we actually want someone to try and squeeze the ball and help us understand what effect it has on us. Who wants to come and squeeze the tennis ball? It's really nice and strong. Thank you. Okay? What effect does squeezing the tennis ball have on the tennis ball? Okay, so Saint's going to try and squeeze it, and we're going to try and see whether anything happens when he does it. Okay? And then we must observe the tennis ball very carefully. And also ask Saint to tell us and comment what he thinks is the effect of squeezing the tennis ball. Okay, Saint? Squeeze it and see. Okay, turn around and see you. Okay, he's squeezing the tennis ball. Can you all see it?
Yes.
Now what's happening to the tennis ball is he's squeezing. Push it.
It's changing shape.
It's changing shape. Why is it changing shape? Because he's applying a force. So what can we say is the effect? So what can we say about the effect that a force can have on an object based on this little small experiment? Fatima.
the shape of
It can change the shape of an object. So that is the first effect that a force can have. It can change the shape of the tennis ball. Now, on your second worksheet there, I've got a little diagram with all the objects that we're discussing and looking at. So the lesson on the screen and what we're working through in terms of our worksheets is corresponding. Okay? So the question on your second worksheet says, what effect does squeezing a tennis ball have? Okay, and this you can do individually. Okay, although we are involving some of you to help us to understand this concept. So we are still allowing you to be involved in the process of learning and coming up with the definitions that we're looking at. Okay, so we all happy with that? It changes its shape. Now let's look at the next aspect. Okay, what do we have here? Okay, I'm going to read the question that's on the screen.
What effect can a force have on this object?
What effect can a force have on this object? Another volunteer, please. Really, the author tells me that he's distantly related to Cristiano Ronaldo in terms of his skill, of course. So he's just going to hold the ball. Obviously, we're going to put it on the ground because we'll be able to see it on the ground. But we know that this ball is predominantly placed on the ground. But the other ball is going to represent a player that's about to do whatever they're going to do to that ball in order to make it do something. Okay? So, what effect can a force have on this particular object? Anybody? If a force is applied to this object, when it's placed on the ground, especially before a penalty is taken, what effect can a force have on that object? Who has not said something? How many? It can cause a stationary object to start to move. Now, what kind of force is he going to apply to make the ball start moving? Somebody that has an answer. What kind of force? A push force. Okay? So when you strike the ball with the inner part of your foot, like we teach you and coach, you are using a what kind of force? A push force. Okay, so you're using a push force to do what to the object? To make it start to move. And obviously, if you're taking a penalty, you want the object to move pretty quickly. Certainly quick enough to go into the goals and allow your team to score. Thank you very much for your work. Thank you very much to my volunteers. We really value having volunteers because they make the lesson more personal. Helping you. Alright, so as you rightly said, we can then put this response on our worksheet. It can make it start to move. Okay. Well done to those that are already filling in their answers on their worksheet. Okay. Well done to you. Okay, remember to put your first response. What can a force do to a shape like a tennis ball? You get to answer that first one. Okay. Let's answer the first one. Okay, I'm just walking around to make sure that everybody understands. Kind of don't forget to answer the first one. Okay. Well done, Angela, Lefika, great. Oh, this is being well made. Well done, Rahim, Theodore. Excellent. Good. Appreciate it. Well done, good. Mohammed and Ari, done. Excellent. Fantastic. Okay, so we make the object start to move. Alright, we make the object start to move. Now, for this next one, I'm going to need two very, very skilled volunteers. Okay, preferably someone that actually knows how to hold a bat. Okay, Ari, I think you're the most popular man for this job. Okay, so I want you to stand in a typical batting stance. Okay, typical batting stance. Now, who can bowl pace? Do you have any bowlers? Mohammed, are you not a bowler? Spin. Okay, so come. You can represent the bowler. So I want Ari to stand this side, and he's going to be facing the bowler. Okay? So the bowler's on the other side. You're not going to bowl, so he's in the classroom. Other things that can break in here. Okay, we're not going to do anything silly. Okay, but you're going to hold the wicket. Okay, so you're going to represent the bowler, you're going to represent the batsman. Now, I want to ask the question, what effect can a bat have on a moving cricket ball? Now, we need to think carefully because there may be more than one effect that that this can have. So we're looking at what effect the bat is going to have on the ball. Say bat. Say bat. Say ball. So we're looking at the effect that the bat is going to have on the ball. One more time, the on the ball. Right, so he rolls to him, obviously trying to take his wickets, he's trying to take him out. But what are the things that he can do as a batsman? Okay, somebody that go on. He can hit it, yes, but what effect is that going to have? You know he's going to try and hit it. He may miss. What can he do? What can he do to the ball? What's going to happen to the motion of the ball? Obviously, depending on the type of bowling he's going to do. He can play ball, a fast ball, medium pace ball, spin. He can change the direction that the ball is going based on his bowling technique. Okay? But we are talking specifically of the effect of the bat on the ball. So what effect can the bat have on a moving ball? Somebody that has to say something. Joseph, what do you think? What effect will it have? Obviously, hitting the ball will do something. What is it going to do to the ball itself? Try again. What do you think? Okay, when you say change its pace, what do you mean? Be more specific. I like that answer. Be more specific. What do you mean it will change its pace? What is pace? What is the pace of the ball? Right? Yes, you said something for this stuff. Right? You said the speed of the ball. So what effect is the bat going to have on the speed of the ball? You spoke about pace. You elaborated on that, Princess, and said that pace is the speed of the ball. So, Angela, what do you think the bat can do to the speed of the ball, depending on how he hits it? Can the speed increase? What do you think? You don't have to be a cricket player to understand this. This is science. Obviously, the cricket player has an advantage, but here we're dealing with science. We can all reason with scientific intelligence on what could happen. What do you think? You also play softball, yes? So you have an idea. You play tennis, you play these other sports, you have an idea. You want to try again, Angela? What do you think? Can't hear you, sorry. It will increase. So she thinks the speed may increase. So what do we mean? If we say the speed will increase, what is that? What do we say? What can happen? The ball can go faster. Who said faster? Well done. Okay, the ball can go faster. What else can happen? Fatima. It can change the direction. A really skilled batsman is good. It's all about hitting it. Guys like Chris Gale, you know, and so I don't know all the players. Sachin Tendulkar is retired. I don't know all the latest ones. Wokes. I don't know. You guys know all the cricket players. The guys that are playing right now. Okay. Who? Virat Kohli. Well done. Okay. So it can make the ball go faster. It can make it go in a different direction. Is there anything else that the bat, another effect that the bat can have on a moving object? It changes movement. I think that's similar to the other answer where it says it can make it go in a different direction. But we spoke about the speed of the ball. We said the ball can go faster. What else can happen? Please. You can change the height of the ball, that's again direction. Okay, if it came as a low ball and you hit it high into the sky, that's changing the direction. Okay, so whether it goes up, down, left, right, that's still direction. Is there anything else that can happen? Can anybody think of anything else? We said that the ball can go faster. Is that all? Fatima, what do you think? The ball can also go slower. Okay, you can take the pace of the ball. Now, I like this example because the bowler can also do those same things with the ball. That's why if you watch sport, you'll find that really skilled bowlers sometimes change the pace at which they bowl because they're trying to use force to take this guy out. Okay. Gentlemen, thank you for volunteering. Both go sit down. Okay, thank you. Let's give them a hand, all the volunteers. Anything that you have done to help us understand this concept. So, Okay, so it can, let's go. First thing there, it can move faster. That's the first one. What's the second thing that can happen? It can move slower. Okay. Or it can move in a completely different direction. Right. Or it can move in a completely different direction. Very good. Okay, it can move in a completely different direction. That's the effect that can have on a moving cricket ball. Now, why do you think Mr. Somerai is using examples from everyday life to teach forces? What is the purpose of using examples that you can relate to? Push it.
It can be easier to understand.
Easier to understand. Okay? Remember, we can't teach you brand new things without relating them to things that you already know. Okay? We looked at that video last time when we were talking about how our brains use knowledge that we already have, the prior knowledge, to help us associate what we already know with any new things that we're trying to know. Okay, so we always try to make learning examples relevant and easy for us to understand and apply ourselves. So far, so good. Okay, so we've looked at what are forces. We've now looked at the effects that a force can have on a moving object. Okay? Now, this is important. I want Luton to please read what's on the screen right now. What does it say?
Please note that the direction of the force will determine what effects the force will have on an object.
Very important. Okay, very important. I'm going to read that again.
Please note that the direction of the force will determine what effect of the force will have on an object.
Okay, will determine what effect the force will have on the object. Now, I've chosen two of the world's most famous footballers as examples, Lionel Messi and Cristiano Ronaldo. Both have done incredible things with forces. Okay, the free kicks that these guys have scored defy logic. Okay, they defy the very laws of the universe, really. They have applied skills that just that blow the world away. And that's why they're so talked about. People like to compare their who's better, etc. And I just thought, I just put both of them okay, to illustrate this point that the direction of the force will determine the effect that the force will have on an object. Okay, so depending on what effect I want, I've got to apply the necessary direction. So if I'm a bowler in cricket, okay, I practice different bouncing techniques. Okay, I practice where I pitch the ball. Because I know if I pitch the ball in a certain place, it's going to have a certain effect when it bounces off the ground. And that's where you get things like bounces. Sorry to use all these sporting examples. I also love sport. Those of you that have been coached by me will know that I try to use a lot of science to explain things and try and use these different things to help us get an advantage of our position and the teams that we play. Okay, forces are used in everyday life. Okay, and the direction of a force is very important. The ball may go
Faster, slower, or in a completely new direction.
Say that again.
The ball may go faster, slower, or in a completely new direction.
Completely new direction. Those are all the effects that a force can have on a moving object. Okay. Now, we want to summarize. In summary, what are the common effects that forces have on stationary and moving objects? And here they are. Force may change the shape of an object. Okay, what example did we use there to show that? Squeezing the tennis ball. Force can make a stationary object start to move. What example did we use there? Soccer ball. Yeah. Okay, very good. Thirdly, we said that if an object is moving, a force can do what? Slower or in a
completely different direction.
Okay, very good. Now, the next question here is, can you think of anywhere else that we can use forces? Now, what I want you to do is at the back of your worksheet there, you're going to go into your collaboration groups and you're going to come up with 3 examples in your collaboration group of where else we can see forces being used. Quickly, you've got 2 minutes in collaboration groups. Zone 1, zone 2, zone 3, zone 4. Spread yourself out. 2 minutes. In your collaboration groups, in the back of worksheet, write down anywhere else that you think force can be used. Whether it's sport, maybe a line. 2 minutes, just collaborate with me and share in your collaboration groups what you think 2 or 3, let's do 2 or 3 examples of where forces can be used. 2 minutes. 2 minutes, quickly, we're almost done. Quickly. Because the social distancing, well done, Chakunda. Good protocol observation. Well done. Okay, you must be able to hear each other, but Anita, for the moment, remember social distancing, masks on, bringing that nose is exposed, bringing the nose covered. Okay. 3 examples. 1.5 minutes. Okay, write down 3 examples in your group quickly, and then you're going to get to share those at the end. One minute, Dave. 1 minute to go. Quickly, guys, just examples. You don't have to explain the examples. Just take, I said it doesn't matter. Any sport, or anywhere now. Any 3 places where 2 or 3 places where forces can be used. You can say in construction, you can come up with different examples. In sport, in a specific sport, any 3. Okay, we should be wrapping up now. I want at least minimum 2 examples from each of the groups. Yeah, we must work quickly, guys. We don't have a lot of time. Okay, let's wrap it up. Last 5 seconds. 4, 3, 2, 1. They're not real seconds, it's just like a countdown. 1. Wrap up. Okay, let's start slowly making our way back to our desks. Okay, just 1, 2 or 3 examples. You don't need to explain it to get detail. You just want to see to understand that forces are used in everyday life. Forces are used in everyday life. Okay, let's just get a couple of volunteers to share. So you get about 4 or 5 examples. 5 hands up. Just an example of where forces are used. Okay. Someone hasn't said something like that. An example of where forces are used. Let's listen up and hear what he has to say. Closing a door. That's the use of the force right there. Every day we open and close doors. Great example. Tana.
A syringe.
A syringe. A lot of those going around at the moment with vaccines and everything. Great example. Somebody that hasn't said something, normally hasn't said much. Yes? So, now explain what you mean when you say shopping. When do we use force when we do shopping? Okay, so we're pushing one. What is that thing that we push when we go shopping? Pushing our trolley. That's a good example from everyday life. Okay, another 2 people to Mohammed. Boxing. Yeah. There's a lot of force there. A lot of push. Okay? Physically, yeah. Very physical sport. Okay? There's also a lot of pushing in boxing. Okay, do you want to share the last example? What did you say? Tennis. Kalalelo is a tennis player and she's using that as an example. Excellent example, Kalalelo. That's another example when we use forces. Okay, so well done and thank you to everybody for that. Alright, now, I'm going to need a volunteer for this next phase, but I'll call the volunteer just now. Before we do that, we want to talk about how we measure force. Now, you all spoke about newtons, okay? And how many of you recognize the instruments that are there. We have spoken about them and we've learned about them in previous standards, but maybe not many of us have actually used these in real life. Okay, I have an example here that is connected to something. We will look at this now to experiment something and see what we're doing. Okay, so I have an example here. Okay, what do we call the instrument that we use to measure force? Please.
A Newton's scale or a string.
Newton scale, yes, sometimes they call it that, but what are the more common ones that we find? That most schools have it, yes.
Spring scale.
Spring scale, yes. It's normally called a spring scale or a spring balance. Okay, another very, very common one is a, who said force meter? Yes, well done. Force meter. A force meter is another example, okay? So these are all examples of instruments that we can use. A Newton meter is also sometimes used, but we use force meter, spring scale, or balance, doesn't matter. Both of them are the same object. That's why I put both of them. One of them is a force meter, the other is a spring scale, or spring balance. You see that they're basically the exact same thing.
Yes, sir.
Yeah, and they're all used to measure force using which unit? Newton. Okay, we spoke about Sir Isaac Newton a little bit earlier. Alright, very, very important. Excellent. Okay, happy everybody?
Yes, sir.
Fantastic. Okay. So now, do we believe that there's a force that can oppose motion? Now, before we do anything, I'm going to get the volunteer that I spoke about a little bit earlier. Now, I've got a brick attached to a spring scale. Okay? Now, what I want us to do for this experiment to prove something and to get us discussing and talking about forces that oppose motion, I want somebody, Shalisha, you're going to be the volunteer because you're sitting so close. Please kindly come and stand here. Now, Shamiso is going to pull the brick. Alright, and I'm going to get a second person just to come stand closer so that the brick doesn't fall on the ground. Joseph, come. These are called proximity advantages. You know, when you're close, you just take advantage. So these are called proximity advantages. Say proximity advantages.
Proximity advantages.
Okay, those of you who don't like sitting in the front, these are the benefits. Okay. So now Shamiso is going to pull. Sorry about this, guys. Sanitizing, I know we've been sanitizing all day, but you know the drill. We have to keep sanitizing. I'll sanitize my hands like 15 times. We must. Okay, so what Shamiso is going to do is she's going to pull, she's already started pulling, and Shamiso is going to tell us, Shamiso, is there a reading? Now I want you to pull, but don't pull the brick. I want you to pull, but the brick mustn't move. So pull gently first. Okay. Now Shamiso is going to be the person we trust because she's the one who's looking at the spring scale. Shamiso, is there a reading on the spring scale?
Yes.
Okay, so that means she's applying force, yes or no?
Yes.
Yes, is she applying force? If there's a reading on a spring scale, is she applying force?
Yes.
Now would you kindly, ma'am, read for us the measurement that you think roughly in newtons? That's newtons and it's reading by the way. What is the reading on the scale roughly? About 5.5 newtons. Yeah, that's what she's putting the brick. Now, why is the brick not moving? She's pulling, but the brick isn't moving. Why? Go on, you sound quite confident in what you're about to say. Yes. Okay, so the force she's applying isn't big enough. That's his reason. Very scientific, I think that's a very valid argument. But could there be something else that's preventing the brick from moving? Ushi. Now, please explain. What is friction? You just said friction. What is it?
Friction is a force that opposes motion.
Ah. So Ushi believes that there's another force called friction that's opposing the motion. So it's acting against the pulling force that Shamiso is applying. Oh. So do you think that the force of friction is actually bigger than the force she's applying at the moment?
Yes.
Would you agree?
Yes.
So what must Shamiso do to eventually get the brick to move? And Joseph's going to rescue the brick. What must she do if she wants the brick to eventually move? She must? Let's go back to what Lord earlier said. What did Lord say she must?
Apply more force.
Together she must?
Apply more force.
Okay, so let's apply more than 5.5 newtons. More. Whoa, and there goes the brick. Pull again, and there goes the brick. One more time, and there goes the brick. Alright, now, she needed to apply more force. Or or a force bigger than the force of friction. Okay, so she applied a force bigger than the force of friction to eventually get the brick to move. Very good. Okay, thank you, volunteers. Let's give them a hand. Okay, so is there a force that opposes motion? Yes or no?
Yes.
And according to Ushe, what is the name of that force?
Friction.
Fantastic. Okay, the name of that force is friction. Okay, so we say initially, why does the brick not move even though we apply pulling force? It doesn't move because of the force of friction. Very, very good. Now we're doing worksheet 3. Almost done. Okay, we said that here friction is a special force that opposes motion. Right. Go to worksheet 3. Okay, worksheet 3. And in your think pair share groups, I want you again to complete that worksheet based on all the information that we have now and work in your think pair share. So quickly result to your think pair share. You've got 3 minutes. And work in your think pair share and finish with the think pair share. Think pair share. Right. Work together and use the information that you now have and the knowledge that you now have to work together to answer those questions. Okay. What do we use to measure force and what units do we use? We use a watt or a watt to measure force in something. In the experiment where the brick was pulled on the spring scale, why did the brick not move? We'll talk about that. Okay. Leave number 3. In fact, I'm going to put it up. Alright, for number 3, let's say here's some examples of friction. My apologies, I want you to put those up before you go. Alright, use those examples on the board. Okay, for example, if a ball is rolling on the ground, it eventually stops because of friction. Our shoes have grip, allowing us not to slide when we walk on smooth surfaces. When you hold a glass of water, there is what between your hand and the glass? Same. When you hold a glass of water, there's what between your hand and the glass? There is friction. And lastly, the brakes on your bicycles and in our cars use friction to stop us from moving. Okay. So you can use any of those as typical examples. Okay, it's a very short worksheet, 3 minutes will be done. Okay. Now, for number 4, alright? For number 4, are you guys together? I want you to all look at the screen. For number 4, I want you all to look at the screen, okay? Alright, we're going to fill in this worksheet, we're almost done. But now that we know about the force of friction, the next instruction here was it's time to conclude the lesson. So we're going to go back to the diagram showing the pusher or pull and work in groups that each for the direction that the force of friction is acting in each one. So what I want you to do is very quickly go back to your desks and fetch worksheet number 1. Okay? And on that, you've got the original 8 diagrams that we looked at. Okay? So just go back to the diagram, try to push your pull, work in groups to identify that direction that the force of friction is working in each one. Okay, so we've got our original ones, stay in your frequently shared groups, and I want you to agree with your partners the direction of friction. And you can show the direction of friction and put a little F next to the arrow to show that that is the direction of friction. Okay, remember we just wrote pull, push, pull, push, pull, push. Now draw an arrow showing the direction of friction on each of those. I'm giving you 1 minute for that. Okay, we're almost done. I'm giving you 1 minute for that. I'm giving you 1 minute for that. Yeah, really quickly. Okay, show the direction of friction on your first 8 diagrams. Put a little F next to the arrow to show that it's the force of friction. Okay, well done, Remy. Looks good. Excellent, guys. See the direction of friction. Good, good. Well done. Over here. Okay, the force of friction. In which direction is friction acting? Remember, friction opposes motion. So it must show that whatever direction the force that's being applied is going, friction is going in the opposite direction. Well done. So you're pushing up. Okay? Remember guys with the press ups. You are pushing from the ground going up. So what is pulling you down? Yes. Oh yes. Well done. Okay. Gravity is your friction. Alright? Because it's pulling you in the opposite direction. Alright? So there's a force that is opposing your motion. Okay? Our shoes have what? Allowing us not to slide when we walk. Make sure you pull those in. Okay, when there's a gap in the words, we fill those in. Our shoes have what? To allow us not to slip. Okay, have a look at the examples again. Notice some of you didn't check. Have a look at the examples on the board, we should be finishing up. Have a look at the examples. Our shoes have what? I'm not telling you answers. You're working together in your collaboration groups, check each other's answers. Make sure that everyone is on the same page. Writing the same things. Our shoes have what? Look at the examples that are written. Our shoes have what? Our shoes. Well done. You hold it. Aha. Yes. Well done. Very good. Excellent. Guys, when you're done, you can slowly make your way into it. Okay, some of you are working faster than others. That's good. Alright? We should be wrapping up now. Very good, very good. Very simple, very easy. Okay? Ari just asked a very good question. We don't have to do the force of friction for worksheet 2 just for the first one. Okay? Because we have identified the pull and the push. Alright, and then we're done, guys. That's it. Let's slowly make our way back as soon as we're done. Well done for the empirical work. We've done together. We work on this. Okay, we want to just wrap things up and make sure that we've understood. So the push is going that way, so friction is going in the opposite direction. You all agree?
Yes.
Okay, very good. Look at the next example. Fortunately, my answer is right for both of them. Okay? He's pulling going there, friction is going in the opposite direction. Okay? Okay, let's look at the next example quickly as we conclude. What kind of force do we see here? Both of them are pulling, so depending on where we're looking. If I'm looking at the man that's pulling in that direction, friction will go that way. Okay? But if it's the donkey pulling, then the donkey's friction is going to be the other direction. You all understand? Yes.
So sir, it's both sides.
It's both sides depending on which one you're looking at. Okay, that's why I said sometimes when you're looking at these questions, always pay attention to the detail of who's doing the pulling. Who are we identifying as the puller? So in this case, obviously, it looks like the farmer is pulling the donkey. So we would say that the force of friction is in that direction. This is pulling away in that direction. Okay, we won't look at all of them, but I think you get the basic idea. Okay? Yes?
Yes, sir.
Alright, so we want to wrap up and conclude, and I'll go to the very last slide. Now, we want to just wrap up. You can read for us the 3 learning outcomes that we wanted to establish at the beginning of the lesson. What are the 3 learning outcomes? Read the first one for me, Angela. Okay, what is the first learning outcome?
Learners will be able
Nice and loud, please.
Learners will be able to explain what a force is and how it is measured.
Okay, can we all explain what a force is and how it's measured? On a scale of 1 to 10, how well do you think you can explain what a force is and how it's measured? Yes. 10 out of 10. Wow. Anybody else? 10, 10, 10, 10. So we're happy. Okay? We've achieved the first learning outcome. Second learning outcome, somebody quickly. Which is second learning outcome?
Learners will be able to identify the common effects as forces having stationary.
Okay, we're identifying the common effects that a force can have on stationary moving objects. Yes? What did we say? What are those common effects? Yes?
Change its shape.
Change the shape of the force. What else did we learn about? Yes?
You can go faster or slower.
Faster, slower, or change its direction. Well done. Okay, this thing. Okay, what's the last thing we looked at as well? Yes.
Motion.
Okay, something is not moving. We said that it can do what? Stationary object can start to move. Fantastic. Okay, scale of 1 to 10, how well do we think we failed that one? 9. Honest, yes?
8.
8.
10.
10. Okay, 8, 9, 10, yes? 10 as well. Well done. Well done. Thank you. Alright? So we've done all those scale of 1 to 10, and the last thing we looked at is what is the third learning outcome, Nifika?
Learners will be able to recognize what friction is and how it affects motion.
Okay, what is friction? What is friction? Somebody that doesn't say something. Harry, what is friction?
Friction is a force of something
Okay, it's a force, and what does it do?
that pushes a force.
Pushes a force down. What does it do to motion? Opposes motion. Well done. Okay, you recovered very well. Okay, so friction is a force that acts in the opposite direction to the main force that's acting on an object. Okay, and we said that friction. There are daily examples of friction. Give me one example of how friction can be useful. Right now, what am I doing? And how's friction helping me? I am doing what? I'm walking, and what is making me not slip? What are my shoes? Very nice. If I was to have a glass of water and this is very hot today, how would friction help me? This will help me keep holding the glass. Okay, so well done, and thank you to everybody for a lovely lesson. Alright, we will then look at the advantages and disadvantages of friction in our next lesson. Well done to everybody for participating. You can hand in all your worksheets now. Thank you very much.